Okay, so if anything is remaining in assignment 1, we will go back to that also. So let's start with assignment 2. Okay. Alright, so I'm starting with question number 6 since a couple of students have requested the discussion of question number 6. So let me start with that one. Okay. Then I will come back to assignment 1 if anything is remaining, sir. Okay. So question number 6 of assignment 2, it says that magnitude of the resultant of two vectors of magnitude 10 each and at an angle of 60 degrees with respect to each other. So this is a very simple situation. Magnitude of both the vectors is 10 and the angle between them theta is equal to 60 degrees. So we have to find the resultant or the magnitude of the resultant. So that is R. Okay. So that is root of, just substitute in the formula, a square plus b square plus 2ab cos theta. Okay, I'm getting your messages. Okay, we'll discuss question 9, 12, etc. after this. So 10 square plus 10 square plus 2 into 10 into 10 into cos 60. So cos 60 half hota hai. Okay, so just use that value which you know. So next step, you just further reduce this to 100 plus 100 plus 200 into half. That's square root of 300, or you can write that as 10 root 3 or approximately 17.32. So this becomes the magnitude of the resultant. Okay, so this is all you have to do in question number 6. Nothing more complicated. Next, we'll come to question number 9. Number of students have asked for discussion on that. So question number 9, like, is that again the angle theta between the two vectors is 45 degrees. Now you can see when the angle theta is 45 degrees, that means cos theta, which is 1 by root 2, is less than 1. So definitely that means your magnitude of a plus b will be less than the sum of the magnitudes. But at the same time, it will also be greater than root of a square plus b square. इससे ज़्यादा होगा. Because you can see that here by this magnitude of a plus b will become root of a square plus b square plus root 2 times ab, because cos theta was equal to cos 45, which is 1 by root. So now you can compare this. So this quantity, this is definitely larger than root of a square plus b square, because this is a positive quantity, but at the same time it is less than a plus b. So accordingly, you can see which options will fit. So here there's only one option. So the option E will be the correct. B, C, D are becoming wrong options. Okay, so that's that. Next, let's move on to the 10th question. A lot of students have asked for the discussion of the 10th question. So just make sure you understand this. Don't worry too much about writing down in detail, because I'll be providing you with the notes that we. So 10th question में क्या कह रहा है? Resultant of two vectors is perpendicular to E and has a magnitude of double of E. Okay. So that means magnitude. So A plus B is the resultant R. Now it is given to us that R is perpendicular to E, and the magnitude of the resultant is 2 times, isn't it? Magnitude equal to double of A. In a problem like this, we have an option of 2 things. We can either go by the geometry method, so that is our first method, let's say. Why I am saying geometrical solution is easy? Because the perpendicular is. So the triangle that I will be drawing then will be a perpendicular, will be a right angle triangle. If I go with the geometrical method, my vector E is suppose like this. Then my resultant is perpendicular to this, and it is double of this in magnitude. So my resultant should be something like this, or E plus B. This should be equal to such that if this has a magnitude E, then the resultant is perpendicular to it, and it has a magnitude of 2. So then in this diagram, where is the vector B line? The vector B must be like this. This will be the vector B. Just a second, guys. I'll share this in a minute. Yeah. So my vector B will be this one. So now whatever I want to find in this triangle is easy by this. So you have to find the magnitude of B. So magnitude of B will become how much? It will become root of magnitude of A square plus R square. That is, so A root 5. So mod A is 2, mod B will become A is 2, A root 5 or 1 is 2. So this is the easy method, the geometrical method. You can also do this by formula, but that is unnecessary. I'll show you that method also, but that's unnecessary. Yes, Mayank, I'll come to 11th question. Let me finish this. You can also do this by formula. यहाँ पे क्या हो रहा है? The resultant is perpendicular to E. The resultant is perpendicular to E. So that means that angle alpha is equal to 90 degrees. So tan alpha, which is B sine theta, upon E plus B cos theta. This is telling us that tan 90 degrees is equal to, yeah, so this B sine theta upon E plus B cos theta. Now tan 90 क्या होता है? It is an undefined quantity. It is undefined heading to infinity. So that means B sine theta upon E plus B cos theta कितना होना चाहिए? Undefined होना चाहिए. So that means the denominator of this must be 0. That's only possible if this thing is 0. So A plus B cos theta should be 0, or B cos theta should be equal to minus. So this is the first equation that we're getting from the first information, that alpha is equal to 90 degrees. This first information. Also given to us the magnitude of the resultant is double of the magnitude of A. So that means mod of A plus B, which is root of A square plus B square plus 2AB cos theta. ये कितना होना चाहिए? ये 2 times A होना चाहिए. So square both sides. So A square plus B square plus 2AB cos theta would be equal to 4A square. Or in other words, B square plus 2AB cos theta would be equal to 3A square. So this is my equation 2, which is coming from this second information. So ये method यहाँ पे थोड़ा lengthy है in comparison, but it's still doable. So now substitute this over here. In this substitute, B cos theta is minus A. So B square plus 2A into B cos theta, which is minus A, is equal to 3A square. So as you can see, B square is becoming equal to 5A square. So magnitude of B will be root 5a. Mind you, it cannot be minus root 5a. B is the magnitude of a vector. So it's a positive quantity. You cannot have negative sign. That's why we eliminate that root of minus. So this is the second method, the geometrical method. The formula-based method or the algebraic method. So I'll just leave you to compare both the methods once. Go through the first method, then again the second method. So finish this, then we come to question number 11. Okay, so go through the whole thing of the formula-based method. So two equations you are getting from two informations. So थोड़ा lengthy हो जाता है formula-based method, which is why I told you that here the geometrical method is easier. Okay, so hope this is done. Understood this? Now moving on to question number 11. Number of people have asked. So in question 11, the magnitudes of the two vectors are given as 12 and 16. And it is also given to us that the angle theta is obtuse, okay, or theta is greater than 90, less than equal to 180 degrees. So we have to estimate it. So we have to see whether magnitude of a plus b is greater than 20 or less than 20 or equal to 20 or none of these. ये सारी चीजें we have to analyze. So how will we analyze which of these is happening? So for that, we'll have to understand that because theta is obtuse, cos theta is what kind of quantity? It's a negative quantity. Theta is obtuse. So that implies over here that cos theta is negative. Therefore, magnitude of a plus b, which is root of a square plus b square plus 2ab cos theta, is equal to root of a square plus b square plus some negative quantity, because cos theta is negative. So that means magnitude of a plus b is definitely less than this, okay, because a is 12 and b is 16. So magnitude of a plus b is less than 144 plus 256 or 400 or 20. So mod a plus b is less than 20. That becomes the correct answer. So this is the concept we have to use in this question. Okay, so that is 10th, 11th. Now let's move on to 12th. Discard नहीं किया बेटा, less than बोला है. See, I am comparing the quantity root of a square plus b square plus 2ab cos theta with root of a square plus b square. Compare कर रहा हूँ दोनों, equate नहीं कर रहा हूँ. Understanding? We are comparing the two, we are not equating. So we know that this is a negative quantity. Okay, so therefore this quantity is less than root of a square. So magnitude of a plus b, we can say, is less than root of b square. We are not eliminating anything, we are just comparing. Let's move on to question number 12 next. So 12 में क्या हो रहा है? Vectors a and b are perpendicular to each other and c is minus 2b. So a is perpendicular to b and c is equal to minus 2. इसका मतलब क्या है? That suppose the vector a is like this, some arbitrary vector like this, then b has to be perpendicular to it. So b is, let's say, like this one. B is any vector of magnitude anything but perpendicular to. तो b अगर ऐसा है तो यहाँ पे c कैसा होगा? C has to be opposite to b, ना? So c has to be like this. C has to be such that this is 180 degrees, which means that this is 90 degrees, and the magnitude of c is equal to pi. So therefore, c is perpendicular to b. We can see that with confidence. So option A is the correct. Okay. Next, let us move on to question number 13. Okay, now 13, it is given to us that magnitude of F1 is 100 newtons, magnitude of F2 is 80, and magnitude of F3 is 60 newtons. And also given to us that the sum of three forces acting is 0. So vector sum F1 plus F2 plus F3 is is equal to 0. Okay. And we have to find the angle between F2 and F2. We have to find theta between F2 and F2. So because we have to find the angle between these two vectors, what we do is we'll express this as F1 is negative of F2 plus F2. So that means the magnitude of F1 is equal to the magnitude of minus of F2 plus F3, which is the same thing as magnitude of F2 plus F3. Mod में वो minus sign gets eliminated. So magnitude of F1 should be equal to magnitude of F2 plus F3. Now magnitude of F1 is known to us. F1 is 100 Newton, so we'll substitute that 100 data. But on the other side, magnitude of F2 plus F3 will become F2 square plus F3 square plus 2F2 F3, where theta is the angle, cos theta, where theta is the angle between F2 vector and F2. Now the next thing you do here is you substitute these values. These values you substitute here. So you have 100 is equal to square root of 80 square plus 60 square plus 2 into 80 into 60 cos. So square both the sides. So you can see that 10 raised power 4 will become 6400 plus 3600 plus 9600 cos theta. So 10 raised power 4 is equal to 10 raised power 4 plus. So that means cos theta is 0. That means theta is how much? 90 degrees. That becomes 1. So basically F2 is perpendicular to F. This is the thing. Simple formula based question, nothing much. Just this step, that if A plus B plus C is equal to 0, it means that A is equal to minus of B plus C. Okay. Or B is equal to minus of A plus C. Or C is equal to minus of A plus C. All three are correct. All these three relations hold true. But here we use one because F2 और F3 के बीच angle निकालना. Yes, and in the previous question, if C was equal to 2B, then C would be parallel to B. Instead of being opposite, it would be parallel. So when we multiply a vector with a number, if the number is positive, then the direction of the vector remains the same. If the number is negative, then the direction becomes reverse. And that's the simple relation. Okay, so that's 13th. Now let's come to 14th question. So in question 14, you have a diagram shown to you where two vectors are drawn like this. So this is a vector P. Its magnitude unknown, but we know that the angle it is making with this axis. This angle is 30 degrees, where this is the perpendicular to this figure. और ये वाला जो vector है, suppose it's Q, but इसका magnitude at 10. Now it is given to us that the force of magnitude 10 acts like this. Okay, so that's given. So this is our north direction. This is our east direction, west and south. Now it is given to us that the resultant of P and Q this is the resultant, then this acts towards north. Okay. So from this we have to find magnitude of P. So all we have to do is now convert this given diagram into the vector triangle, the summation triangle. Okay. So P plus Q अगर कर रहे हैं या Q plus P अगर कर रहे हैं कैसा होगा? See, this was the vector Q, this was the vector P. This angle between them is 120 degrees, 90 plus 30. And this one's magnitude is 10, this one's magnitude is unknown. So how we will do P plus Q now? For P plus Q, we will first draw the vector P. So that's, let's say, like this. Then we want to add the vector Q to it. So this vector has to be placed on the head of P. So this vector has to be like this. Like this. Okay. So you can see that if this is the vector Q, the angle between P and Q, this angle, it's 120 degrees. Okay. Now what will be the resultant here? The resultant should be this vector from the origin of P to the head of Q. Now that vector should be such that it's towards north. So that's what I've done. So this angle should be 90. And this is P plus. And the other thing known in this, एक ही बात है बेटा, P plus Q करो या Q plus P करो, एक ही बात है. You get the same thing because E plus B is the same as B plus C. So you can do Q plus P also, it doesn't matter. But more importantly, ये एंगल यहाँ पे कितना हो जाएगा? ये एंगल 60 हो गया. So that angle is 60 degrees. From that now you can show that how much should be the magnitude of P. This angle is 60 degrees, this interior one, and this is 10. So in this right angle triangle, you can see that our cos 60 is 10 divided by magnitude of P, which is the unknown. So 10 by P is equal to cos 60, which is half. So magnitude of P is 20. So Mike, what we are saying is that instead of doing P plus Q, if we did Q plus P, how will we get the result? So it's the same reaction, not too different. Instead of this triangle, now if you do Q plus P, get this triangle. This is Q. And to that you have added P in such a way that now these two vectors should add in such a way that the resultant should be like this. You see, this and this are same. They are the same triangle but just flipped. So if you place this triangle alongside it, it's the same as this triangle, but like a mirror image. वो triangle ऐसा दिखेगा. So this is also an interesting way of understanding why vector summation or addition of vectors is what we call a commutative property. That is P plus Q is the same as Q plus P. Yes, Vedant, that is correct. So whichever of the diagrams you use is the same. Alright, so that is about the doubts from question from assignment 2. Now, does anybody have any doubts pending from assignment 1? Sarah, I think you had some doubt from assignment 1. Please let me know. So let me know which questions, question numbers. If you can open assignment 1, tell me which questions you are having difficulty with. Question 15, okay. Question 15, okay, I will come to that. Okay, let's finish this question 15 first of assignment 2. Then we'll come back to assignment 1. So tan inverse का मतलब क्या होता है? I think you might have seen in trigonometry already. So before we get into question 15, let us understand like this. Tan inverse of something. Okay, this is read as tan inverse of x, or we can have something like this, sine inverse of x. So these come under the category of what we call inverse trigonometric operators. So as the name suggests, inverse का मतलब क्या होता है? Just जो operation tan था उसका inverse. So this means that if suppose we know that tan 30 degrees is equal to root 3, so that means we can say 30 degrees is tan inverse of, sorry, 60 degrees. We know that tan 60 is root 3, or tan 30 is 1 by root 3. So this is just the inverse of this. Okay. Or supposing we know that sine of 60 degrees is root 3 by 2. So that means 60 degrees is sine inverse root 3 by 2. Okay. Or no, that is to the that is not inverse beta, that is 1 upon. Okay. Cot theta is tan theta to the power minus. So that is 1 by tan. This is different. Okay, this is raised to the power negative, and this symbol here is different. This is inverse of the function. So they are different. Okay. So yeah, it's a little confusing. यहाँ पे दिखने में power जैसा लगता है, because when we write sine square theta, we write like this. So this is the same thing as sine theta whole square. But unfortunately, sine inverse of theta is not the same thing as sine theta to the power minus 1. It means something else. Okay? It means this. So for example, if we say that theta is equal to sine inverse of 3 by 5, let's say. So that means that sine theta is equal to 3 by 5. Or that means that theta is equal to 37 degrees. Or if we say that theta is equal to cos inverse of minus half, so that means that cos theta is equal to minus half. So that means that suppose theta is in second quadrant, so theta is an obtuse angle, it means that minus of cos 180 minus theta is equal to, so cos 180 minus theta is half. So that means 180 minus theta is how much? 30 degrees. sorry, 60 degrees. Cos 60 is half. So theta. So this basically means that if theta is cos inverse of minus half, then theta must be equal to 1. In other words, cos theta must be equal to minus half. So that is the meaning of that inverse trigonometric function. Okay, so again, in this question, if we say that suppose alpha is equal to tan inverse of root 3 by 2. What that means over here is that tan alpha is, this is the meaning of this. Okay. So now with this knowledge in mind, let's proceed with question number 15. Just try it out yourself. It says that there are two forces P and Q such that the ratio of their magnitudes P is to Q is 1:2. And if the resultant is at some angle, so let's say that is alpha equal to tan inverse root 3 by 2 with respect to the vector P. So now what we have to do is we have to find theta. That is the angle between P and Q. So this basically means if you were to think in terms of geometry, how this should be looking. If P is some vector like this, let us say Q is some vector like this. Then the ratio 1:2. So if P is some x in magnitude, Q will be 2x. Now the resultant of these two. So in this diagram would be, let's say, this vector. So ये resultant कैसा होना चाहिए? It should be such that it's making an angle of tan inverse root 3 by 2. So this angle alpha would be tan inverse root 3 by 2. That means that tan alpha is root 3 by 2. So how do we solve this? Now we know the formula that if the angle between P and Q is theta, this angle is theta, then tan alpha should be equal to Q sine theta upon P plus Q cos theta. Where tan alpha we know now is root 3 by 2. Okay. And P is to Q is equal to 1:2. So if P is equal to x, we can substitute Q as 2x. So substitute that. So left hand side tan theta, tan alpha now we have root 3 by 2. Right hand side that is Q, which is 2x into sine theta upon P, which is x, plus Q, which is 2x. So x also cancels out in numerator and denominator, and we have the relation root 3 by 2 is equal to 2 sine theta upon 1 plus 2 cos theta. Now we have to solve this for theta. So how we'll solve for theta is, whenever there's an equation in which sine theta and cos theta are both there, if sine theta and cos theta are in an equation, use the identity sine square theta plus cos square theta is equal to 1 to solve. So let's make use of that identity now. So this equation cross multiplying Now to make use of this, what we'll do is square both sides. Square this equation. Okay, so on squaring, it becomes like this. So 3 times 1 plus 2 cos theta whole square is equal to 16 sine square theta. And now we bring in this, that sine square theta is 1 minus cos square theta. So next, from 1 plus 4 cos square theta plus 4 cos theta is equal to 16 into 1 minus cos square. Okay. So 12 plus 16 cos square theta plus 12 cos theta plus 3. So plus 3 minus 16. So plus 3 minus 16 will become minus 13. So 28 cos square theta plus 12 cos theta minus 13 is equal to 0. So this is like a quadratic equation. Ax square plus bx plus c is equal to 0. That x is cos theta. A is equal to 20, b is equal to 12, and c is equal to minus 30. So cos theta will become minus b plus minus root of b square minus 4ac divided by 2e. So next we'll have to solve this. Now you can take 2 common from this. So this will become 3 square plus 28 into 13. No, c is negative now. It's b square minus 4ac. That is the displacement. यहाँ पे c negative है. Okay. Just go through the steps up to this first. We'll come back to the calculation. Go through these steps first. Yeah, Kanish can make a correction. It should be 36 remaining over here. That's correct. Okay, so is it clear to this step, everyone? So in the next step, we are taking 4 common. So from 12 square or 144, if you take 4 common, you are left with 36 and not 3 square. Just make a correction here. This term will be 6 square. Okay, so anyway, when you do this calculation, this will come out to be minus 12 plus minus square root of 36 plus 364. This comes out to be easy, but finally it comes out to be something easy. We take a positive root. So 8 by 56. Which equation as well? No, no. If that was tan inverse root 3, then that angle is directly 60, na? वो थोड़ी है. Wait, let me just verify. Hey, the question is correct, but something in my calculation, okay, this should not come out with this. Cos theta should come out to be half. Yeah, so where I've forgotten the two, what you saying? Oh, right. This two outside. Correct. Yeah, that is the mistake. Wait a minute. Just make a correction here. We'll get this correct. यहाँ पे एक extra two है ना, this two है. So this is 2 times. So it's minus 12 plus minus 2 into 20. Right. Okay. So minus 12 plus minus 40 by 56. We'll take the positive root and not the negative root. So cos theta will be 40 minus 12, which is 18. That's half. So theta is equal to 60. Yeah, theta should be coming to 60 degrees in this. Question is correct. So anyway, quite a bit of calculation involved in this question. But you know, these kind of tricks you will learn in trigonometry and maths. This thing which I told you here, that when we have an equation, ये वाला जो point है, this is actually some from trigonometric equation in maths. This is the method from trigonometric equations chapter in maths. So when you do enough trigonometry in maths, you will get used to these things. Don't worry about that solving thing here. Anyway, let's turn our attention to assignment 1 now. So there are few doubts in that. Question 8 and 9. Okay. So go through question 8 and 9 of the first assignment. I'll explain. Also 5, 6. Okay. So let's start with question 5. Let's start with the 5th question. This problem. Okay. This problem is actually not so much a vectors problem. It is more just a general geometry problem. So इसमें I'll give you a hint and you try and solve it yourself. So suppose this is our carom board, which is, how much is it? 8 by 8, is it? 6 by 6. 4 by 4. Okay, so just try and draw it better still. Okay. So suppose this is the carom board. Now there's a coin sitting at the center. And now you want to pocket it, let's say in this corner, but not directly. You wanted to take a path like this. So you will have to hit this coin in such a way कि उसका path ऐसा होगा. will rebound. Like this. So you want that this should be the path. Now I will give you a hint here that the rebound from the front edge, let's say at this point P. So आपको यहाँ कहीं पे aim करना है. अगर आपने ज़्यादा right की तरफ aim किया, then it will end up reaching here. If you aim it too much towards the left, it will hit here and come somewhere here. So there's an exact spot P जहाँ पे आपको aim करना है, so that it reaches this spot. So this rebound can be treated like a reflection. This is like a reflection at a mirror. That is, angle of incidence is equal to angle of reflection. So जो rebound है, उसको आप you treat it like this. As if this is the mirror, and whatever is coming and hitting it, it should have a path such that this is the perpendicular you are dropping. This angle should be equal to this angle. So, yes. So once you do that, then next thing you can see, you can do in the question is, you can now use geometry. Now, how you can use geometry here is, further, suppose you draw these symmetry lines. Now let's say जहां से point start हो रहा है, that is the center point, let's say C, and this point is P, of course, and where it's getting pocketed, let's say this is the point D, and this corner is P, and this corner is some D. So the hint I'll give you, apart from this, first is this, and second, if you look at triangle CPD, okay, and triangle EPB, they are similar triangles. So use that, okay. And in those similar triangles, you can also see that because this is a 4x4 ka board, so this will be 2 feet. This will be 2 feet. The total side length is that. Okay. This angle is 90. This angle is 90. Okay. And because these two angles are same, this theta and this theta, so this angle is equal to this angle. This angle is some alpha, let's say. So this angle is also alpha. So that's how they are similar triangles. Now use similar triangles. Use this to find the sides BC and BB. Okay, so use this as a hint and try and solve the question yourself. Abhi the question is not done completely. Okay, the question, yeah, it's a 1:2 ratio of a triangle, Kanish, that's correct. But still, you have to do something more also, not just this much. This I'm just giving you the hint to try this question. This is a nice question, so try it out. If you can't find the answer, then I will give you the complete solution. Okay, so just take this down as a hint, okay, and try and solve it yourself. This is not so much a vectors question; it's just like a basic geometry kind of question, but with some trick. Next, let us come to question 6. So question 6, I will just make the diagram for you. From there, you should be able to solve it yourself. So the car moves 2 kilometers towards east. Let us take our geographical directions, reference like this. So ये अगर east है और ये अगर north है. So what is happening is, let's say our car starts from this point O. It first makes a displacement of 2 kilometers towards east. That is, let's say something like this. This is my first displacement, let's say S1, which is 2 kilometers in length towards east. So it will reach some point, let's say from O to this point, let's say E. Then from that point, it is making a displacement of half a kilometer. 500 meters is half a kilometer. Okay. Perpendicular right turn बनाते हैं. Sorry, made a perpendicular left turn. So left turn means it will go northwards. See, if something is going in this direction, तो यहाँ से left turn by 90 degrees कैसा होगा? ऐसा होगा. So going like this, the left turn will be like this. So the second displacement it's making is going to be towards north. So it's a 90-degree turn towards the left. And it's only half a kilometer, 0.5 kilometers. This is the second displacement. So from the direction of the first, he's making a turn by 90 degrees, like this, towards the left. So that is the second displacement, which is going towards the north. And that takes him to the point B. Then again, he makes a turn in which direction? Right turn. Perpendicular right turn and went for 4 kilometers and then stopped. So from here, he makes a perpendicular right turn. That means वापस east के तरफ, and he went some 4 kilometers or whatever and stopped. So from this direction, you can see he's making a 90-degree turn. This is 4 kilometers. And finally, he's stopping here. So we have to find the net displacement. So what is happening? The total or the net displacement is which one? It is from O to C. So net displacement is basically S1 plus S2 plus S3. That is the vector from the point O to C. So in this diagram, that is this vector. यहाँ से लेके यहाँ तक ये उसका net displacement. So this one's magnitude we have to find. So to find the magnitude, just use Pythagoras theorem. Draw a perpendicular here. So this whole thing is how much? 0.5 kilometer, and from here to here, this whole thing is how much? It is 6 kilometers. 4 plus 2. So the net displacement, this is this one, this net displacement. इसका magnitude क्या हो जाएगा? इसका hypotenuse. Okay. So just make a note of this. Then we'll come to question 7 next. Okay. Then we'll move on to question 8. So next we will do question 8. Then 8 and 9. Okay, so let's move on to question 8. So question 8 में बोल रहा है that there is the minute hand of a clock which is 10 centimeters long from the axis to the tip. So to find the displacement of the tip in quarter of an hour, then next half an hour. अच्छा, also question 7 is it? So 7 में देखो क्या हो रहा है. In 7, with respect to your xy coordinate frame, एक वेक्टर A ऐसा है. It is at 30 degrees to the x-axis. Let's say the vector E is like this. And its magnitude is given as how much? 10 units. Now vector B is such that it is at 120 degrees with respect to E. And its magnitude is also the same thing, 10 units. Magnitude is the same, but the direction is not the same. It's like this. So this angle is 120. And this is the vector B. Now that is also 10 in magnitude. So now see what we can say about the vector C, which is the sum of A and B. So now my vector C is supposed to be the resultant of E plus B. So there are two things we know about the resultant. One is that the magnitude will become this. So when you substitute these values here, this will become 10. The other thing is that tan alpha will be B sin theta upon A plus B cos theta. So यहाँ पे वो कितना हो जाएगा? It will become 10 sin 60, which is root 3 by 2, upon A plus B, which is 10 cos 60, which is half. So you can cancel off the 10. So it is root 3 by 2 upon 1 plus half, or root 3 by 2 divided by 3 by 2, or that is root 3 by 3, which is 1 by root 3. Okay. So tan alpha oh sorry, my mistake, this is minus, because cos 120 है, so ये minus half हो जाएगा. Sin theta is sin 120, which is sin 60, so that is root 3 by 2. But cos theta is cos 120, which is minus cos 60, or minus half. Okay. So this term is minus half, so cancelling the 10, you have 1 minus half, so that is half. So that becomes root 3. Okay. नहीं वेक्टर सी नहीं आएगा बेटा, cos थीटा यहाँ पे आपको माइनस हाफ सब्स्टिट्यूट करना है. Cos theta is minus half, not plus half. It's 120 degrees. No? The angle between A and B is 120. So anyway, so that means alpha is tan inverse of root 3, which is nothing but 60 degrees. Okay. So that's some additional information that you know. So not only we know that the resultant ka magnitude 10 hoga, but we also know that the resultant will be such that it's making an angle of 60 degrees with respect to E. That is the alpha. No? So this resultant is of magnitude 10, but more importantly, this angle alpha is equal to 60 degrees. So now what is the angle the resultant is making with the x-axis? You can see that is 90. Okay. So in this diagram, you can see that the resultant is of magnitude 10, okay, and perpendicular to the x-axis. Yes, it makes an equilateral, right? It's equilateral. So geometrically, you can just understand it that way also. Without the equations, if you want to solve, you can do it this way also. You can just solve this geometrically. What is happening is that if you look at the vector E like this and the vector B like this, now immediately you realize that यहाँ पे ये एंगल 120 है, ठीक है, और ये दोनों का मैग्नीट्यूड सेम है. So that puts a huge significance on the triangle. Without solving triangle law and all that, we can easily show that it's equilateral triangle, because if these two sides are equal, then these two angles should be equal. So 2 alpha, their sum should be equal to opposite exterior angle 120. So that means alpha is equal to 60 degrees each. So that means the triangle is equilateral. So that immediately tells you that magnitude of C is equal to 10 and alpha is equal to 60 degrees. Yes, they're all equal. So here you are using that property that if this angle is alpha and this angle is beta, then this angle here, the opposite exterior angle becomes alpha plus beta. So this is the geometrical way of solving this. So as I've told you before also that sometimes the geometrical method is faster, sometimes the formula method is faster. It is a matter of practice that you will start understanding, you know, which method is preferable. Okay, so come to the 8th question next. So in 8th question, you're talking about the minute hand of a clock and you want to find the displacement of its tip. After completing 15 minutes. Okay. So if this is your clock, this is the dial of your clock, suppose. So these are the main 4. Or in terms of minutes, okay. And these are the smaller ones. So you'll see that at the center, this angle is 90, this angle is 30, this angle is 30, like this. These all angles are like this. So at some hour, any point of time, if the minute hand is here, somewhere here, at some arbitrary something like that. Let's say this is 12 hours and some, let's say 9 minutes, 12:09. Okay. So 15 minutes later, where will be the minute hand? 15 minutes later, the minute hand would have moved here. This is where it will be at 12 hours and 24 minutes. So it would have rotated through how much? 90 degrees. So now the question is asking the displacement of the tip of the minute hand. So वो displacement कितना होगा? वो ये वाले point जो tip है वो यहाँ से यहाँ आ गया. So it is that displacement. So in this diagram now, this is the displacement of the tip of the minute hand in 15 minutes. This is the displacement of the tip of the minute hand from, in my case, 12:09 to 12:24. But more importantly, 15 minutes. In 15 minutes. Okay. So कहाँ भी हो ये magnitude तो same होगा. Okay. So now it's very easy. You can see that in this triangle, this side is equal to this side, which is 10 centimeters. So the magnitude of the displacement should be how much? It should be 10 root 2 centimeters, because it's the hypotenuse of a right angle isosceles triangle. But a very simple calculation. Okay. So like that, half an hour बाद क्या होगा? ये यहाँ पहुँच गया होगा, diametrically opposite. So displacement will be 1 diameter. 1 hour बाद क्या होगा? It will come back to where it started from. So the displacement will be 0. So like that. So we just interpret the definition of displacement in this, nothing else. Okay. So this is the 8th question. Right. So hope this is clear, Sarah. Now moving on to 9th question. Question 9, I'll just explain the question and you can try it yourself. Okay. Right now it's so question 9 में देखो क्या कह रहा है? Resultant of P and Q is R. Okay. So P plus Q is equal to R. This is the first statement given to us. Okay. Now the other thing is saying that on reversing Q, the resultant of this vector minus Q with P is S. So basically, if let's say this is some vector Q, what is the vector that you get on reversing Q? You get this vector. You get a vector which is equal and opposite. So you get a vector like this. This is minus Q. They both have the same magnitude, but they are opposite direction. So if I add this new vector, I'm getting the vector S. But you can also see that ये P plus minus Q क्या होता है? P minus Q होता है. So that is equal to S. No? So use this. Now you have to prove something about this thing, that R square plus S square is equal to 2 times P square plus Q square. So to prove this, use triangle law for sum and difference both. Okay. So just use the triangle law statement, you will get this very easily. Just do what I'm saying right now, you will get the answer quite easily. Okay, so hope you understood the question. So just use triangle law. Na? So magnitude of R is this. If theta is the angle between them, and magnitude of S is this. So R square and यहाँ से S square minus. Okay. So if you add these two equations, immediately you can see your cos theta term gets eliminated. Add these two equations, so you get this becomes the final proof. Okay, good. Ganesh, you worked out question 5. That carom board one, nice. Right, so hope these questions are clear to those of you who had doubts. So anyway, after the lecture, go through the notes once more and make sure you do the questions yourself also, try out all the steps. Now next we'll move on to the second representation of vectors. So last time, up to last time we were looking at geometrical representation. Now the second method of representation we'll see is the component method, or the component representation of vectors. So in component representation of vectors, the vectors are represented in terms of the coordinate axis. So vectors are represented in terms of a reference frame. Our reference frame is nothing but it is a system of coordinate axis. Okay. So then the question is which type of coordinate axis? So they are called Cartesian. Okay. Coordinate axis. So Cartesian में क्या होता है? The coordinate axes are mutually perpendicular. So that is the meaning of Cartesian. Okay. So we will first use the two-dimensional method. So components in a two-dimensional coordinate axis system. So any particular direction we like in a two-dimensional system can be taken as our x-axis. Depending on what is convenient for us, we can take the direction of east as our x-axis. We can take the direction of north as our x-axis. Doesn't matter. We can take the vertical as our x-axis. We can take horizontal as our x-axis. But y-axis has to become perpendicular to that. And once we do that, we define what we call two standard unit vectors or base unit vectors. यूनिट वेक्टर का मतलब क्या होता है? वेक्टर जिसका मैग्नीट्यूड 1 हो या मैग्नीट्यूड यूनिटी हो. So we define two unit vectors like this, which are denoted by the symbols I cap and j cap. So we define base unit vectors. I cap, which is a unit vector along the positive x-axis. It's not just x-axis, it's pointing along the positive x-axis. So unit vector basically means that its magnitude is equal to a single unit, okay, and the direction is along the positive x-axis. And similarly, we define j cap as a vector of magnitude unity. It's a unit vector, but this time it is along the positive y-axis. So in the component system, that is the first thing we do. We define the base unit vectors, or what are called the standard unit vectors. Then using this, we will write the component notation or the component representation of any vector. Okay. So you can just make a quick basic note of this thing. This is the thing what we're doing next. Or you can start from here. We are talking about the component representation of vectors. Right, so just like in 2 dimensions, we have I cap and j cap as the unit vectors along x and y axis, which are mutually perpendicular. When we come to 3 dimensions, next time we will see that there is also the z axis, which is perpendicular to both x and y. Okay. Reference frame. The vectors are represented in terms of a reference frame, FRAM. Yeah, so when we extend this to 3 dimensions, there will also be a z-axis, जो कि दोनों x and y के perpendicular होगा. And along that z-axis, there will be a unit vector which we denote by k cap. Okay. But that we'll see later. Okay. First, we will get used to the 2-dimensional system. Position vector is the position of a point in terms of the reference frame. So in kinematics, you have this definition called position vector. So अगर कोई point यहाँ पे, so how do I define this position vector? So for that, first of all, I have to define the origin of my coordinate system. So this is the origin of my reference frame or coordinate system. Then the position vector of the point P becomes nothing but the vector OP. ये वाला vector. This is the position vector. So in kinematics, this is how we define position. We define it as a vector quantity, which is nothing but this. So this is the position of the point P with respect to the origin of my coordinate system. This is the first definition you will see in kinematics in any standard reference book. Alright, next thing, once you've defined as standard unit vectors, how to define a vector in component form. So any vector, like let's say A, is represented in component form form as an equation. जैसे ज्योमेट्री में क्या करते थे, ज्योमेट्रिकल फॉर्म में we represented by a vector arrow, by a drawing, but here we actually represented by an equation which is given like this. Some quantity, let's say ax multiplied with I cap plus some quantity ay multiplied with j cap, where ax and ay are scalars and called the x component and y component of the vector A respectively. Okay, so this is how we represent a vector in component form. This is the vector A expressed or written in component form. Geometrical form में हम उसको कैसे लिखते हैं? By drawing an arrow. So like that in component form, how do we write it? By an equation like this. So for example, if we say that the force F is 20 I cap plus 15 J cap in newtons. So we'll say that the force F has components Fx equal to 20 newtons and Fy equal to 15 newtons along the x and y axis. So this quantity Fx is a scalar. It's just the magnitude of the force. It's 20 newtons. This is just a magnitude. But when I express it as 20 into I cap plus 15 into j cap, ये क्या बन जाता है लेफ्ट हैंड साइड पे? ये वेक्टर बन जाता है. So the vector is expressed as some scalar quantity. So the vector A is represented as some scalar quantity multiplied by I cap plus another scalar quantity multiplied by j cap. So this whole equation on the right hand side, Ax into I cap is a vector because Ax is a scalar and I cap is a unit vector. Ay into j cap is a vector. So the sum of the two is a vector, and that vector is nothing but E. So you can say that the vector A is expressed as the sum of two vectors. One along the x-axis, जिसका magnitude Ax है, और दूसरा along the y-axis, जिसका magnitude Ay है. You understood the meaning of the term components. So just note down this part with this example. Okay, people. So this is clear. Now let's understand a little bit more between the relationship of the components and the vector. So when we express the vector as Ax I cap plus Ay j cap, here let's understand the quantity Ax into I cap. The quantity Ax into I cap is nothing but it is a vector of magnitude Ax along the positive x-axis. because I cap is a unit vector ना, उसका खुद का मैग्नीट्यूड कितना है 1 है. So ये पूरे चीज का मैग्नीट्यूड कितना है ax यूनिट्स है, पर उसका डायरेक्शन क्या है along the x axis. And similarly ay j cap, it's a vector of magnitude whatever that ay is, okay, along the y-axis. So therefore the vector E is the sum of two component vectors, ax I cap and ay j cap. So let us understand this as an example. Suppose I have the vector E as 4 I cap plus 3 j cap in whatever unit. Could be newtons for force, could be meters for displacement, whatever. Now देखो, with respect to my x and y axis, with respect to this xy system, अभी I cap कैसा है? It's a unit vector in this direction. और j cap क्या है? It's a unit vector in this direction. Just a minute. Just give me a second, guys. I'll have to restart that whiteboard software. Just a few seconds. Huh? Screen will come back. Alright, so I cap अगर ऐसा 1 यूनिट का वेक्टर है और j cap 1 यूनिट का वेक्टर है, then what is the quantity 4 I cap? 4 I cap should be a vector of magnitude 4, but lying along the x-axis, so it should look like this. Should be like this. This should be the vector 4 I cap, and like that 3 j cap is the plus 3 को मैंने multiply किया है j cap के साथ. So remember, when we multiply a vector with a positive quantity, उसका direction same रहता है, but magnitude becomes that many times. So 3 j cap is 3 times j cap. So its magnitude is 3 units, but its direction is along j cap. So that is the positive y-axis. So in this diagram now 3 j cap should look something like this. So you can see that here Ex is 4 and sorry, and Ey is 3 like this. So now what is the vector E? It is the sum of this Axi cap plus Ayj cap, or 4I cap plus 3j cap. So now construct the vector A using these two. So vector A कैसे दिखेगा diagram में? You take the vector 4I cap, so that's this one. Okay. So this is 4I cap, and then you take the vector 3j cap, क्योंकि ये वाला vector है. But now you have to add it to this. इन दोनों को sum करना है. So yeah, it is like, from the origin to the coordinate 4, 3. You can also think in terms of coordinate geometry. ये अगर point origin है, तो इसके coordinates क्या है? ये वाले point के 4, 0, और इसके coordinates क्या हो जाएंगे? Because this is 3j cap, इसके coordinates 4, 3 हो जाएंगे. So now what is my vector A? It is the sum of these two, ना? So it is like the hypotenuse of this triangle, joining the origin point here with that point 4, 3. So anyway, in terms of vector triangle, it is the third side of that right angled vector triangle. This is the vector A. Okay. So this is the relationship between any vector and its components. Okay. So in general, we draw it like this. अगर मेरे पास कोई वेक्टर Si. This is some random vector. See the vector E with respect to my xy axis. So what we do is you drop a perpendicular from this onto the x-axis and drop a perpendicular from this onto the y-axis. So you can see that ये जो है ये मेरा x component हो जाएगा. इसका magnitude ax होगा. And as a vector quantity it is ax I cap. और ये जो है मेरा magnitude में ay हो जाएगा. So that is why I can treat this as a vector ay-j, which is the same as this vector. And that is why the vector E is becoming the sum of the vectors ax I cap plus. So this is the geometrical meaning of the components. जब हम वेक्टर को दो components के terms में लिखते हैं, so what is the meaning of those components? Is that so just make a note of this part first, then the part below. Yes, that is the vector A. जो black arrow था ना वही vector A था, left hand side वही था, because it was the sum of these two. So that is the relationship between the vector A and the two components ax and ay. So ax is a line of magnitude ax along the x-axis. Ay-j cap is a line of magnitude ay along the y-axis. So what is the vector A then? In दोनों का sum क्या है? It is nothing but the diagonal of that box. It's like the diagonal of that rectangle, जिसका कि x वाला base कितना है? ax है, और जिसका y वाला side कितना है? It is ay. Kanish, I didn't understand your question. If it is okay if a vector is represented in units, नहीं, I cap और J cap के units नहीं होते बेटा. They are just of magnitude 1. Okay. Why see I cap and J cap don't have units? Because see, we can use I cap and J cap to define a force. Suppose I say the force is this much in newtons, but then I can also use it to define a displacement, which is let's say 2 I cap plus 3 J cap in meters. सो यहाँ पे जो मीटर का यूनिट है वो किसके पास जा रहा है, कंपोनेंट्स के पास जा रहा है, आई कैप और जे कैप के पास नहीं जा रहा है। ये जो न्यूटन का यूनिट है किसके पास है वो, सो यहाँ पे जो फोर्स का मैग्नीट्यूड है वो 10 न्यूटन्स होगा, या फोर्स का जो एक्स कंपोनेंट है वो 10 न्यूटन्स होगा। तो न्यूटन डज नॉट बिलोंग टू द यूनिट वेक्टर। सिमिलरली डिस्प्लेसमेंट का जो एक्स कंपोनेंट है दैट इज 2 मीटर्स, डिस्प्लेसमेंट का जो वाई कंपोनेंट है दैट इज 3 meters. The unit vectors don't have any physical unit. They just have a magnitude of 1. Yes, they are only representing direction. That is correct. Okay. The purpose of unit vector is to represent the direction in vector form. Okay, so this example is clear. Now, when we generalize this, this is how the vector expressed in some component form, how it looks geometrically, it looks like this. Okay. So therefore, we now come to one very important aspect, and that is the relationship of the magnitude of the vector with respect to the components. So this is now very important, that magnitude of the vector becomes the hypotenuse of a right angle triangle. So this is the first important. And the other thing is, if this angle is making with the x-axis is theta, okay, so along with that, tan theta is Ey by x. So these formulae are the first point of importance for us. So for example, if we have a vector b, which is root 3 I cap plus j cap. Okay, now we want to find magnitude of the vector, and we want to find the angle of vector b with respect to the x-axis. So what formula we use? We use this formula. So we can see that this vector is such that the x component of b is root 3, the y component of b is 1. So the magnitude of b by that formula will become square root of x component square plus y component square. So that is square root of root 3 ka whole square plus 1 ka square. So that is root 4. And root 4 we won't write as plus minus here, we'll just write it as 2. Is because we are not saying b square is 4, we are saying b is square root of 4. So it is units, whatever that is. Okay. And we have tan theta is by bx. So that is 1 by root 3. So that means theta here is tan inverse of 1 by root 3. So that means the angle it is making with the x-axis is 30 degrees. And you can always verify all this by just drawing the vector. You can also simultaneously draw this vector. So this vector will be drawn by that triangle. इसका की base कितना होगा bx root 3 और इसका perpendicular कितना होगा 1. So obviously the hypotenuse will be how much 2, and obviously the angle will be how much 30 degrees. Okay. But don't worry, Ansh, I will send you the notes. So as long as you understood, it's enough. So this formula and this formula, they become important. So now I'll just take a couple of more minutes to finish up, though we have finished with the duration of the lecture. Now, because just I don't want to leave this in the middle. Okay, so that was one thing. Now the other thing is that how to find components Ax and Ay, how to find these from the magnitude of the vector and the angle it is making with the x-axis. How to find that? Okay, so that's like a reverse of the last process. पिछले वाले में क्या किया हमने, ax और ay पता है तो मैग्नीट्यूड ऑफ a और एंगल थीटा हमने निकाला, बट यहाँ पे उल्टा है. सपोज I have a situation where I know the length of this vector and I know the angle it is making, so I know how much a is in magnitude and I know how much theta is. So for example, suppose the magnitude of the vector e is suppose 5 units and the angle it is making with the x-axis is, let's say, 37 degrees. Then I want to find out ax and ay and express the vector in component form. So it's very simple. Again, it is trigonometry because ultimately you're dealing with what? A right angle triangle. So यहाँ पे this is your ax in length. So this component vector is axi cap, and this over here is ay. So all you do is use trigonometry. So you can see that in this right angle triangle, this triangle, cos theta is base upon hypotenuse. So that means I can define base as hypotenuse into cos theta. So this becomes one formula. And again, sin theta is perpendicular upon hypotenuse. So ay is a sin theta. So these become the formula to convert magnitude and angle into components. Okay. So now use this formula, you can try out this question. Yes, tan 37 is 3/4. So, but यहाँ पे क्या use करेंगे? We use this that ax is a cos theta. So that is 5 cos 37. And cos 37 I taught you earlier was 4/5. It is nothing but 4. And ay is a sin 37. So that is nothing but 5 into 3/5. That's 3. So ax is equal to 4, ay is equal to 3, and the vector e will be therefore expressed as 4 I cap plus 3. Is that earlier vector we had drawn? Because they are Cartesian coordinate system, so these components are perpendicular to each other. Got it understood? So let's quickly look at one more example of this. Now in this example, थोड़ा सा ध्यान से करना है. Because now the vector that I am showing is going to be like this. This, let's say, it's of magnitude 10 units and this angle is 30 degrees. Okay? Whereas we have another vector which is of magnitude 12 units and this angle is 30 degrees. Okay? So now the question is express A and B in component form. Just try this out. Anybody got the answer? So देखो B के लिए तो बहुत आसान है. Just drop this perpendicular here, so you can see that this is bx. So that is going to be 12 cos 30. So that is 6 root 3, and dy will be 12 sin 30. So that is 6. So the vector B in component form is very easy. It is 6 root 3 I cap plus 6 A cap. For A, Kanish, the thing is you have to understand A का x component कैसा हो जा रहा है, negative हो जा रहा है. Because the angle A is making with the x-axis is an obtuse angle. And also in the diagram you can see that vector A ऐसा है. So the angle it is making with the x-axis, that is this one, for the vector A, theta is equal to 120 degrees with respect to positive x-axis. Okay. And the magnitude of A is 10. So that is why when you drop these perpendiculars, यहाँ पे ax कैसा quantity हो जाएगा? It will be a negative quantity. और ay कैसा quantity होगा? It will be a positive quantity. So ax, which is e cos theta, will become 10 cos 120. So that is 10 into minus cos 60, or 10 into minus half. So minus 5. And ey will be e sin theta. So 10 sin 120 degrees. So that is 10 into sin 60, or 10 into root 3 by 2, or 5 root 3. So this is your ax and this is your ey. So the vector E will become minus 5 I cap plus 5 root 3. So you can see here that Ex is negative and Ey is positive. The x component is pointing along the negative x direction, minus I cap ke along. Okay. So this is the vector A expressed in component form. Okay, so next time we will understand more about this, looking at vectors which can be in any of the quadrants. Like this one was second quadrant, B was first quadrant. As a third or fourth quadrant में भी हो सकते हैं. And accordingly, the x and y component can be any combination of negative and positive. Okay. So that's it for today's class, people. This is where we conclude today's session. And make sure you revise the class notes and also complete any pending questions from assignment 1 and 2. If any confusion or doubt, please message me. I will help you out with that particular question or doubt. Okay. And I will be sending another assignment, so please attempt those questions. Okay. That's it. Thank you, people. Hope you enjoyed the class.